Imagine a living power plant swimming beneath the water. Its power goes far beyond anything you could ever imagine. It has no wires, no plug. Yet this creature, made entirely of flesh and bone, can unleash a deadly 860-volt high-voltage discharge in a single strike, nearly 4 times the voltage of a standard household wall outlet. Contrary to popular belief, this animal isn't actually a true eel. It belongs to a unique group of knife fish that inhabit the dark, muddy waters of the Amazon and Orinoco river basins, where the riverbed is covered with decaying leaves and organic debris. In these murky waters, visibility is almost non-existent, making eyesight nearly useless. In fact, electric eels have relatively poor vision, but nature has given them the perfect superpower to navigate, hunt, and survive in complete darkness: bioelectricity. Their breeding behavior is just as fascinating. Male electric eels use their saliva to build enormous nests from aquatic plants. The female lays thousands of eggs inside the nest. When the first hatchlings emerge, they are still incapable of generating electricity. To survive, they feed on the unhatched eggs around them. As they grow, their biological batteries develop, allowing them to fend for themselves. Here's a surprising fact that very few people know. Unlike most fish, electric eels cannot obtain enough oxygen through their gills alone. Instead, they absorb about 80% of the oxygen they need directly from the air through a dense network of tiny blood vessels inside their mouths. Because of this, they must surface every 10 to 15 minutes to take a deep breath. If they become trapped underwater, they can tragically drown beneath the very water they live in. But how can a creature made entirely of flesh and bone generate such an enormous voltage without using metal or wires? The answer lies in 3 specialized electric organs that make up nearly 80% of its body: the main organ, hunter organ, and sax organ. These organs are composed of thousands of specialized cells called electrocytes. Each one functions like a tiny battery. When they all work together, they produce an enormous electrical discharge. The instant the brain detects either prey or danger, it sends a signal through the nervous system to activate these cells. Within seconds, thousands of electrocytes become electrically charged at the same time. Like hundreds of miniature batteries connected in series, they combine into a single powerful circuit and unleash a massive high-voltage electrical discharge. But what would a human actually feel if struck by this shock? According to scientists and researchers who have experienced contact with electric eels, an 860-volt discharge may not kill a healthy person outright, but it can instantly lock the muscles and make breathing extremely difficult. In shallow water, even if the victim remains conscious, their muscles may become so severely paralyzed that they are unable to stay afloat, putting them at serious risk of drowning. The incredible power of this animal has fascinated scientists for centuries. In the early 1800s, the famous German explorer Alexander von Humboldt traveled to South America to study these remarkable fish. There he witnessed an astonishing technique used by the local people. They drove a herd of wild horses into a muddy river. Startled by the splashing animals, the electric eels unleashed all of their stored electricity in self-defense. Once the eels had completely exhausted their electrical charge, researchers were able to collect them from the water without harm. This extraordinary event, recorded in Humboldt's journals, became one of the first major demonstrations that revealed the astonishing power of biological electricity to the world. But electric eels don't use electricity merely as a powerful weapon. They also emit low-voltage electrical pulses to scan their surroundings, much like a living radar system. Even more remarkably, they can use electricity like a remote control to expose hidden prey. When a fish hides beneath rocks or buried in the mud, the eel releases a pair of high-voltage pulses. These pulses directly stimulate the prey's nervous system, forcing its muscles to contract involuntarily. The moment the hidden fish twitches and reveals its position, the electric eel instantly locks onto its target and delivers the final strike. When facing a larger, more resilient prey, the eel employs an astonishing strategy to nearly double the voltage delivered to its target. It curls its body around the prey, like a loop, bringing the positive pole near its head closer to the negative pole in its tail. This dramatically increases the electric field passing through the prey, crushing it with what scientists often describe as a living electric clamp. An even more fascinating defensive behavior was discovered by Vanderbilt University biologist Kenneth Catania. When a threat remains just beyond reach, the eel suddenly launches itself out of the water and presses its head directly against the attacker's body, whether it's a human or another predator. By making direct contact, it delivers its electrical discharge straight into the target instead of allowing it to dissipate through the surrounding water. This dramatically increases the intensity of the shock, forcing even the most powerful predators to retreat almost instantly. And that brings us to the question everyone asks. If it can generate such enormous voltage, why doesn't it electrocute itself? The answer lies in its extraordinary anatomy. Its body is covered by a thick, fatty layer of skin that acts as an excellent electrical insulator. Its vital organs, including the heart, liver, and digestive system, are also packed into a tiny region just behind its head. As a result, the electrical discharge largely bypasses these organs and flows harmlessly into the surrounding water, which acts as a much better conductor. Nature's biological generator has even inspired modern technology. The work of Alessandro Volta, who developed the world's first true battery, was influenced in part by early studies of electric fish. Today, scientists are attempting to mimic the eel's electricity-producing cells to develop biocompatible pacemakers that could operate without battery replacements, as well as advanced soft robots powered by bio-inspired electrical systems. Gliding through the pitch-black waters of the Amazon, this remarkable creature reminds us once again that nature knows no limits when it comes to engineering. No wires, no metal, just flesh, bone, and an extraordinary living high-voltage system. What do you think nature's next incredible superpower might be? Share your thoughts in the comments, and don't forget to subscribe so you won't miss the next episode in this series.